Firefighters have been doing their jobs heroically for centuries. Their uniforms, however, were not always up to the task. Good thing today's firefighters are cloaked in layers of space-age material. The protective armor has virtually eliminated firefighter deaths caused by burn injuries. A computer-guided machine cuts out more than 90 parts to make the outer shell, just one of 3 layers in a firefighter's jacket. This fabric contains synthetic fiber known as PBI, which protects against temperatures as high as 648 degrees Celsius. Another machine tapes the seams of the jacket's middle layer, the moisture barrier. Pressure rollers and high heat activate glue in the tape, sealing the seams. This synthetic fabric lets perspiration through, but blocks some harmful liquids such as battery acid, hydraulic fluid, or infected blood. Now they line the moisture barrier with the thermal liner, the jacket's third and innermost layer. This synthetic fabric protects against heat of up to 426 degrees Celsius. To reinforce the cuffs, hems, and front and back panels, a worker sews them together with heat-resistant tape and thread, but she leaves the neck area unattached, so the firefighter can pull the jacket inside out to inspect the liner between rescues. Back to the outer shell. A worker sews 2 orange and silver stripes to the front and back panels. She also sews a stripe onto each sleeve. The fluorescent orange makes the firefighter more visible in daylight, the reflective silvers for nighttime or in the smoke. In some cases, she adds reflective die-cut letters identifying the fire department or spelling the firefighter's name. A strip of Velcro goes onto the left front panel. It's one of 4 ways to fasten the jacket, in addition to zippers, snaps, and hooks. To keep water from entering through the front of the jacket, they attach a strip of the same fabric used to make the moisture barrier. A worker sews it inside the outer shell's right front panel, what's called the storm flap. The storm flap's other side gets a Velcro strip that mates with the Velcro on the left panel. They attach the front panels to the back panels. A worker folds the garment over, and the machine sews through 2 layers at once. It's another way to reinforce the seams of the jacket. They use a different sewing machine to attach the sleeves. A worker sews 5 different seams to join the shoulder areas. This is critical because firefighters carry an 11-kilogram air tank on their back. The seams spread out the stress this weight places on the jacket. A worker attaches 3 metal snaps to the inside front of the outer shell. These will attach the outer shell to the 2 inner layers. Then, a heat-resistant plastic zipper. This machine applies 3 rivets to each of 4 spring-loaded hooks along the right front panel of the jacket. A 1.8-meter-long strap cinches around the armpits to drag an injured firefighter away from danger. A worker then snaps together the assembled inner layers to the outer shell. There are 4 snaps on each cuff, which could heat up quickly in a fire. Tabs ensure they never burn the firefighter's skin. The front panels come together with 4 snaps on each side. The 10-centimeter collar unfolds, covering the neck to where it meets the firefighter's helmet. Fully assembled, the jacket weighs just more than 2 kilos. This testing device gauges how long it would take to sustain a 2nd-degree burn. A gas burner shoots a flame that's 1,093 degrees Celsius directly onto the jacket's outer layer. A heat sensor mimics human skin's sensitivity to heat. The material fails the test if the transferred heat would cause 2nd-degree burns in less than 17.5 seconds. Finally, they shower the uniform for 20 minutes to test its watertight seal. The dummy's wearing a cotton bodysuit underneath. Just one wet spot on the bodysuit, and the uniform fails inspection.